So let's go through this next one. It says when crossing an organism that is homozygous recessive, and I'm thinking homozygous recessive is going to be little t, little t. Homozygous means the same, recessive means little t's. For a single trait with a heterozygote, so that heterozygote is going to be big T, little t.
Yeah.
What is the chance of producing an offspring with a homozygous recessive phenotype?
But I actually got this one right.
Yeah.
Because I kind of did that in my head. It's 50. Actually, first I chose 25, then I thought about it. I was like, wait, no, it's 50.
Yeah, it's 50 for sure.
Okay.
Cool?
Yeah. Hey, go to the right.
To the left or to the right? To this one?
Yeah. My bad. I guess for you to the left, for me to the right.
It's actually the right for me too.
Oh, cool. Okay,
This
yeah.
one's crazy.
This is the one the last one I got wrong, which made me fail. Whoa, okay.
So we just kind of have to read everything. And the things that I'm kind of jotting down is I'm thinking, I kind of write off to the side, big B, or big B, little b would be black. And then little b would be brown. You see how I can read like that first sentence and make that happen? Black fur, big B is dominant to brown fur, so I could write that down.
Yeah.
Then short tails are dominant, so big T, little t, and big T are going to be short, and little t is going to be long. Which actually, if you think about it, it's a little backwards from what usually big T is referring to like the long or the tall guy, and this is a reversal if you think about it. We wouldn't associate little t with being long, but nevertheless it is. It says black fur in mice is dominant, so we got that. It says what fraction for this cross, right? So I would cross the big B, little b with the big B in your head.
They're renewing their vows. They're already married.
Like that? So it would appear to me that the chance of having a big B, because it says we want to have a black fur long tail child, right? Okay, well to have a black tail, to be big B, or big B, little b, looks like all the progeny are going to be that for sure. Right?
Okay, hold on. Why'd you do the B's? Why'd you do B and T? Because you're trying to find black fur and tails.
Right, but see, they're two independent events. To have black fur is independent of the tail.
That's why they're different letters.
So you cross those first.
Yeah, and then I'm gonna cross my T's
And
second.
then you're gonna add that together.
I'm not gonna add it. I'm gonna multiply it because they're events. They're not instances. They're events. They're two independent events, so I can multiply them. Big T, little t with big T, little t.
So
little
we're
t,
taking
little
a
t.
test. People are doing this in their head, I guess.
Yes.
Okay. Which I mean, I guess that's.
Yeah. With practice, you'll with this packet you'll be able to get that, for sure, real quick.
All right.
So, yeah. What's the chance of getting long tails?
50%.
Yeah. So 1/2 here. And what was the chance of being the black? 1/1.
Yeah.
4/4. 1/1. So 1 times 1/2 is going to just be 1/2. Because they're two independent events, so I can just multiply them. Cool? Nice.
Can you get to the last question?
Sure.
I don't know what it is. I remember I messed that up
Is
too.
that the one?
The answer is C. That's all I know.
This one right there?
If it was asking what proportion of the progeny will be expected to be genotypically resemble,
You can say that would be
zero?
it would be 0 because right away with this little a right there.
Yeah,
Well, actually, you could do
because it's asking if it would be.
yeah with the bees. The bees would make it impossible.
Yeah.
The bees would make it impossible because since this parent is little b, all their progeny is going to at least have a little b in it, guaranteed. And you want to be genotypically the same as this parent, which is big B. It won't happen, like for sure. But yeah, they say what is the proportion that will be phenotypically resembling the first parent. So who's going to look like the first parent?
So phenotypically, so it's like
Your look.
yeah, their physical characteristics.
Mm-hmm.
Okay. And genotypes.
Yep.
Okay.
So I do this cross in my head, right? And what's the chance of the progeny having a look that is, the progeny means children, having a look that's just like this first parent, using just A's?
What am I about to multiply?
No, in your head you're doing the cross between big A, and big A and little a.
Oh, so I'm doing both of them.
You're going to just focus on
Okay.
A's
To
right now.
figure out, okay.
Mm-hmm. Yeah, because these two are going to mate.
So it's 100%.
100% they're going to look like it, right?
Yeah.
So I could write just 1 over the A. And what about for the B's? What would that be?
50? No. It'd be 1/1.
Perfect. You see that? Because the big B there means it's going to happen for sure.
Yeah.
So that's always a trick. If one parent has big B, and they want to know about like doing phenotype, like looking like that first parent,
It has to work.
it has to be.
Okay.
Because the parent's going to guarantee to give it a big B.
So big C, little c, big C, little c. So it's what, 50?
Mm,
C, C. So it's
that's going to be big C, big C, big C, little